So some of these rollers are older than others. There's a few on here that are probably 10 to 12 years old. They're just some of the originals, but I just haven't made the brand new ones to put on here. 2 of these are only a year old, but for intensive purposes, they show kind of what the unit would look like when it's operating. So I just start it slow. I don't really want to get above 220 RPM. Some of these just, they don't have the stability, then they'll fly off, but I'll show you what's going on here. So this is all magnetically coupled together. There's no direct connection to these rollers, to the driver underneath. Everything's completely magnetically locked. And electrically isolated. So these inductors are isolated from the platform underneath. So if I want to introduce high voltage, I can do that.
Now, can you tap current from these coils here?
It's about, so far, 9 volts.
Okay.
It's not a whole lot, it's AC.
And then what's driving it is underneath, and that is not mechanically coupled, it's magnetically coupled.
Yep. Yeah,
so as that spins, it takes the rollers with it.
Yep, about 36 watts is all it takes to drive this quite easily. And the motor can run, I've tried this, the motor can run for hours and doesn't get warm at all because I'm underperforming on it. So it has these bands of rotation, it's real smooth, and others it'll kind of oscillate a little bit. There's 200 RPM. And I've also noticed is the faster it gets, the noise level drops too. I know especially on that one I can get it really fast. Now this is only about 214 RPM. With the new improved rollers, I can go up to about 385 RPM. So it's quite a bit faster. These old ones are quite slow.
Let me,
This shows the battery level, the battery charge, and that shows the RPM. That's to show the active unit is active, on-off switch, and that's the direction. If I wanted to flip the direction of rotation, I can change that switch.
can this go?
This motor can do about 885 RPM. With these rollers on here, I don't really want to try much faster. The new improved ones, I can do about 385 RPM with the brand new rollers, constant. And they get quieter as they go. So this is pretty dang loud. There's 220. Now if I have one roller on here, this cable will just be like lurching. But at 12,
it's balanced out.
Pretty balanced. I mean, just a little bit of vibration, a little movement. But that's what I'm waiting for is the new improved rollers. The sound level drops, and I've seen that a lot. Is the new rollers, the sound drops, and I can show that on this when I can put two new rollers here and show you. So far there's no cooling, but I'm not surprised with that. This is not pure neodymium, it's just an uncharged magnet.
Okay.
But if I ever get once I get a neodymium core, I expect it to drop in temperature dramatically fast. And what I've seen with Delphins, that cooling travels right through the insulator, right into the magnets, right into the copper, and cools the rollers too. I mean, everything drops in temperature. So this inductor's hot. This inductor's nice and hot. And these other ones are cool, and then that one's hot. 230. So what I've learned from Surl, it doesn't appear that rotation matters, but what I've heard from the Russian people at Russian SEG, rotation makes a big difference, especially when it comes to gravity. What they would do there is clockwise, it would try to lift off, it would lose weight, but when they do the counterclockwise, it would gain weight.
Okay.
But with Surls, it didn't seem to matter which direction. So that's why I've incorporated this so I can do clockwise or counterclockwise. But even at this RPM, Delphin's started having cooling. When he was even doing 230 RPM, his started exhibiting cooling. So far, this is nothing. I'm not surprised at all.
And you've had this way higher in the past. You've had it up to 800.
385. I got it to 396 was my max.
Oh, okay, okay.
If I do the magnets with no copper and nothing inside, I can do almost 500 RPM just bare magnets.
And you can see
So the copper went down 1 degree. Up here it's kind of a little bit warmer.
we're definitely seeing some wobble on the table.
It is. Because these rollers are not equal. There's some new improved ones, there's older ones. $260. Wow, that is really. The battery's still full. Guess that's it. 270.
There we go.
Old rollers. But when it comes to a stop, it comes to a stop.
Yeah. Well, and you were saying that you've pulled rollers off of several different projects to put on this, right?
Oh yeah, some of these are like 14 years old, 15 years old.
Yeah.
They're just the old school ones.
No, it's incredible to see. I was surprised that it was shaking. When I came by last year, you did that demo and that one spun, it was just smooth as silk.
Yeah, it was this guy. But it got up to about 230 RPM and just stopped, and these coils would super overheat, and I could only run it for a few minutes at a time, but this stays cold for hours. I've literally let it run. I think the max was 6 hours, 4 or 6 hours or something. It was cold to the touch still.
So these rollers have the new magnetization process on them?
No, they're just industry standard. Aside from this one and this one.
Okay.
That was last year's technology, nothing new. These are all very old, normal, completely normal. I did a system last year, and I took it completely apart, but I was able to get the stator to spin counterclockwise and the rollers to spin clockwise, and I could literally have these rollers spinning at near 10,000 RPM without flying off.
10,000 RPM?
Because I would spin this back at about 200 to 300 RPM backwards. So it was on a separate motor and the rollers were on a separate motor. So as this was spinning backwards, I would have these spinning the opposite way. So the stator was spinning a few hundred RPM while these were going at like 200 RPM. But because, you know, this distance and travel will make this rotate, so one rotation will cause that to rotate 6 turns.
Okay.
So 100 RPM would be 600 RPM on this.
I get it. So that's how you were able to get up to such high RPM.
Yeah, and it was disastrous because it was such strong centrifugal force, the copper bands loosened up and would slip off the rollers. It was insane. Like literally they were loosening, and this one shows it. They loosened and fell off.
So what did Searl claim? What was his preferred operating speed?
That is one detail I've never heard. I've heard they just went really high, a high RPM. Well, what is that?
Maybe they weren't able to measure, or you know, maybe it varied, right?
It probably did vary. But one thing he did claim is that the rollers, after a certain speed of rotation and the extreme high voltage would occur really quick, is that they would, what he said, they would lose their weight. And so they literally could just spin as fast as they could go, and they dropped their weight. And so it was irrelevant how fast they went because there was no weight, no centrifugal force.
Well, and I know there is less friction. That's something you've talked about in the past. The faster it spins, because the centrifugal force is pushing those rollers off the magnet. So,
and that's one thing I demonstrated, which I don't have that because I took it apart. I do have on some of my TikTok videos. When I would do I did a unit where I magnetically locked all the rollers so they couldn't orbit. They could spin, but there was like a magnet here and here and here and here. So the rollers would stay put and the stator would spin. This thing would get so hot. Oh, it would warm up within seconds. The copper would warm up to where it was warmer than my skin temperature in just a few minutes. And of course the copper would get really shiny. So basically it was polishing itself and rubbing and causing heat, acting almost like a brake.
now again, if you go to the classic multi-stator SEG, right, rings within rings, I think Searl had said the rollers would basically center themselves in between the inner and outer rings, right?
Yeah.
Are you kind of hoping for that? That'll reduce friction.
Exactly. And I have seen that. I've photographed it. I videoed it at high RPM. These rollers do separate out to about 1/16 of an inch to 1/8 of an inch. And I've kept that sustained. But I haven't tried that with ones that have all the new waves yet. So
okay.
I have pictures and video. I can send that to you. It shows that very clearly. There is an air gap between them, and the noise does drop.
See, and again, it's intriguing. Searl made all of these predictions, right? And you are not the only person who's seen bits and pieces, but it's intriguing that as you build it, especially as you follow, you know, his guide, right?
Yeah.
Then you're seeing it.
Exactly.
One after another after another.
And even the latest thing is, those roller segments only act as a magnetic bearing when they have a wobble to them. If they go straight, nothing happens at all. They don't grab, they don't rotate, but when you have a wobble in that wave, or you just let it oscillate back and forth as this one oscillates, which that's what I'm gearing towards, is that the wave will oscillate like that inside the magnet, not the ring magnet itself. So the wave is just doing this, and that will grab a hold of that and spin, creating, so that the ideal thing is so that when these are rotating around without touching, they continue to spin. It doesn't rely on physical contact with the stator.
Okay.
Thereby reducing your friction or eliminating it. That's ideally, eliminate it completely.
Yeah, so you're already seeing bits and pieces. It's running a little cold, you're seeing the friction disappear, you're seeing, you know, but you're not seeing the big anomalous effects yet, right?
Not yet, and I'm 99% sure that if I had a solid neodymium core, even if it was a cylinder or just this ring, it would have some pretty amazing effects.
Yeah.
I mean, I saw that in Dolphins. The only thing in the Russian one, they had no neodymium, except the magnets, and they're still dropped in temperature.
Yeah.
So it's kind of like, well, is it required? Is it not? I don't know. But I will be eventually finding that out. And like with these cores, I cannot find a manufacturer to do a solid ring like this at all. All I can find is these pieces. So my next best thing is to do glue a whole bunch together and then machine it on the lathe. So there'd be the hexagonal shape. So glue them all together and then machine it down into this size and then replace this with this rare earth component and then test it.
I mean, from what you showed me earlier, the neodymium seems that there are lots of things that could make it essential, but the biggest property seems to be that it produces such a large magnetic field compared to other things, right?
Electric field. It sheds off its electrons real fast. This is one part I have not verified. Science says it doesn't happen, is that it obviously it sheds off electrons and it oxidizes real quick. Searl says that it reattracts new electrons, so I have yet to see that happen.
Okay.
Because oxidizing, that's easy to do, but replenishing it, I don't know about that.
I do remember reading in his book, and I'll zoom in here with the camera, he was saying that the different materials used in the layers, right? You've got copper, I'm not sure, what is the black one?
The black one's the magnetic layer.
Okay, and then you've got nylon 66, and then is that neodymium?
It's neodymium unmagnetized.
Okay.
Yeah.
So he had said that those function almost as a transistor gate.
Yeah, a whole gate. And it controls especially that insulator controls the electron flow. What Fernando says is that they tend to act like bosons, so it's the electrons behave differently in this system compared to normal systems where it's all just electrons. They act like Cooper pairs, and that's how they can go through the insulator. But something Jared has brought up is like they don't really need to go through, they just need to travel across the insulator from here to there. That's the distance. So some of Searl's setups, I've seen that this layer is extremely thin, and his other layers are very, very thin. So I've heard that from a few other people that have experimented with this way back in the past, that this is way, way, way too thick. So maybe in future versions, I may just reduce it dramatically to a 1/4 inch thick or something. In the second and third rings, it is much, much thinner. The second ring is only about, I think, a 5/8 to a 1/2 inch thick, the insulator layer, and then the third ring is even just a little bit thinner. So they dramatically change in size the further out they go. And we've even done calculations for a 4th, 5th, and 6th ring. If we wanted to do that, we could.
Now, I think Searl, the most I had ever seen in schematics is 3 rings,
Three
right?
rings, correct.
Okay.
But he said if you had the money, you could do 4, 5, 6. There's no limit.
Did he have any predictions what would happen with those?
More power availability. There is an anomalous thing only Searl's discussed, and I haven't talked to anyone has any clue about what would be involved. Searl brought it a couple of times, and he said his flying ones had 5 layers.
Okay.
Everyone I've ever talked to.
Wait, 5 layers or 5 rings?
5 layers.
Interesting. Did he say what the 5th layer was?
No indicators what that was.
Interesting.
I literally have no idea, but, well, no, that's not quite true. I don't know what the element was, but apparently it was an additional magnetic layer of some sort. It wasn't an insulator, it wasn't a rare earth or copper, it was an additional magnetic layer to make the electrons move even faster across.
Ah, okay.
But he would never disclose much details except it was some sort of additional, what was it called, accelerator layer.
Yeah.
But that was it. That's the only details I've been able to, even the people that work with him don't even know what it was.
Okay.
If it ever even existed. But according to law of squares, you can do 5, you could do a 6-layer system, or 7, if you could figure out what that was.
Interesting.
Yeah.
Well, and again, a lot of those people, so many of them have passed, right? And they've taken such tremendous knowledge with them.
All of them, yeah.
And again, that is why it is so important, the work that you're doing. You are saving this legacy, you know? And I know there are a few other people out there, like Jason Verbelli. I really respect everything he has done.
Yeah.
And you have a couple of folks in your working group that are absolutely amazing.
Brilliant, yeah.
So, you know, so there are some Searl effect people keeping the dream alive, right?
Yeah.
But your work specifically, I mean, you were building it and making it happen and relearning this lost art.
It is really a lost art. You just brought something to mind I wanted to show, and this is really thanks to Jared. Here it is. So this is something I'm going to try because I've gotten the magnetic fields down to where I can repeat them. Searl's original, very, very first SEG was homogeneous, meaning that it had no layers. It was just element. And all the mixture, all the layers, like the squares and everything was blended together, and he cast it into a solid ring and solid rollers. Now these aren't solid. So Jared suggested that I just get a magnet to magnet with no layer and like this, and put the patterns on and spin it up and see what happens.
Okay.
So eventually, once I get the stator magnetizing perfected, the roller magnetizing perfected, I'm going to do it to this. These are ceramic magnets. They used to be very easy to get a hold of. Now they're very hard to get these big ones anymore. One company in the whole world I found makes them. That's all I could find. These are a dime a dozen. But that's what I'm going to eventually do with this system. I have enough magnets for all 12 rollers, is put patterns onto this, this ceramic, and then magnetize these also for the patterns they need, and spin it up and see what happens. It's just ceramic grade 8 magnets, but I think, you know what the heck, I'm going to try it before these are all out of stock and you can't buy them anymore.
Well, you know, even if nothing impressive happens, there's always that learning that goes on, right? You learn the big things, like, okay, it works or doesn't, but you may also learn little things, like, okay, spacing or materials or, you know, God knows what. And
one of the things I have yet to see, Searl talked about it a lot, was that it's something I copied into all these patterns, is everything's slanted at 21 degrees. But he said the angle on the rollers is opposite to the angle on the stator. So that, let's just say, for the sake of conversation, the rollers would be angled towards the right, the 21 degree mark. The stator would be angled towards the left. And when those angles intersect, they create waves. So like that. So that's something I have not yet done. And I'm going to be doing in all these systems is that angling stuff. So the angle is reversed on the stator. It goes one direction on the rollers, opposite direction on the stator.
Interesting.
So that's something I have yet to try and perform, because I'm just, you know, taking one step at a time with the rollers.
So one of the things that we saw a moment ago was the heat gun. You were using the thermal imaging to see what was running hot and what was running cool. We did see it run a little bit cooler. Have you done anything like laser deflection to see if, I mean,
no.
Yeah, that might be something interesting also. It was like,
I haven't done it at all. Wow. So I'm not familiar with that. I'll just say I'm not quite familiar with that one. Is that where you shoot a beam across it?
Yeah, essentially, and see if that beam deflects at all. And who knows what they could be from. I mean, like in principle, gravitational distortion would make that happen.
Like, like gravitational lensing. And so it bends it. Okay, so one of the things, Surl had several guys who wrote papers. What was it? It wasn't Stanford. It was a guy in Britain came. He made a whole. I have all his sheets, and he diagrammed the circuits, the rollers, the magnetic and printing. But one of the things he verified and saw when the generator was running, he put in strontium-90, a sample of strontium-90 into the core. Took a measurement before, put it in there for about a few minutes, pulled it out, and the measurement was vastly different, like lower in radiation.
Oh, interesting.
So I was telling Jared, and he was like, maybe it didn't just de-energize it, but the time inside there sped up. And so the decay rate went higher because time accelerated. I mean, that's a whole different scenario, but maybe because gravity is changing in this localized area, time flowed at a different rate. And so this process of shedding off the radiation move faster. I don't know.
I mean, so from what you're describing, then the interesting thing would be to see if you could somehow pass a laser beam. Well, I mean, you could start by passing a laser beam right above, but then if you were able to pass it down through the center, and who knows, maybe you'd see some deflection, right?
Well, that would not be hard. I mean, I could put a hole right through here and have one going right down through here.
And then the other one is just like laser interferometry, you know, and that way if you see a change in interference patterns, that can indicate change also.
You're right. So like if I was to go from here and put a target across there, I could look at the target as it spins.
Yeah.
Oh, that's brilliant. I never even thought about that. That's brilliant. I will do that. My only other thought is like if I put dry ice in here.
Then the other thing that I'd wondered, and so your SEG right there is shaking, so this may not work, but I'd wonder what if you had like a glass enclosure, and I think you mentioned this earlier today, doing a glass enclosure on this thing for different reasons. It was like, what if you tried things outside of the glass enclosure, like non-ferrous materials, to see if you'd get any movement?
Oh, like copper, brass, aluminum?
I was thinking just like a piece of string with a rubber ball on it or something, you know, a piece of wood, something that wouldn't interact with magnetic fields, right?
Right.
As long as it wasn't moving from the actual shaking of the enclosure.
Independent of this table, like hanging down from the ceiling in.
Yeah, I mean.
Yeah, I could close the door and.
You know, and hey, odds are you wouldn't see anything, but it would be interesting to test, right?
Okay, so before we go on, those are the things, I just never even think in that route. Let me write these down.
Well, and I don't want to distract you, Isaiah.
No, this is great because
my goal at all.
Because I always just think like, oh, thermal and then EMF. I'm not thinking like those type of measuring systems.
The other thing too is you are so focused on the SEG and the rollers and like the magnetization and the process that goes into that, right? That then it's like, well, what if these other effects, especially if they're really subtle, what if that's going on and you're just like zooming right past it because you're focused on the big stuff?
Because I just bypass it. Or like in the, what was the guy? The guy with the rotating superconductor where smoke goes over.
Yeah, Poglanov. Yeah.
Poglanov, yeah.
And that wasn't his, that was a colleague that walked over who was smoking a pipe, you know?
So that's what I want to try.
So he would have missed it. He wasn't paying attention to it. He was thinking about other stuff.
Exactly. And if it hadn't not been for that smoke, they never would have seen it. Because it was such a small little degree, but I mean, a 1% change is massive. To find that to where you're warping gravity in a localized little area.
But I love the fact that you're doing thermal measurements on it. That is so cool. I've never seen that before.
Only with Delphin I've seen. He was the only other person. I mean, aside from him and the Russian people, I don't know if anyone else aside from Fernando and Jason had done that kind of work.
Yeah, well, and it's newer too, right? Yeah. So the original Surl folks didn't have that at their disposal.
No, they didn't. I mean, that was 50s, 60s, 70s, 80s, yeah, 50s and 60s. Yeah, especially when he built the first unit, that was, I don't even know how he even calculated, like, weights and scales and everything. I'm not even sure how he put that all together and then calculated like RPM. He just said RPM was really high. Well, what are you talking, a million or are we talking 200?
Well, and to get super speculative, like you had talked about having dreams that gave you information. I recall Surl describing that many, many times.
Yep.
And even neuroscience would say your brain solves problems in its sleep, right? They would say pay attention to your dreams. So even if there's a completely prosaic explanation for it, you know, it's the human subconscious solves problems differently and it has access to different information than our conscious mind does. So
absolutely.
Who knows? Maybe, you know, a lot of what he did came out of dreams and intuition.
Yeah. And especially the biggest dream I had that brought the most understanding was that sitting down at a table with Surl, and he told me, you know, I showed him my magnets, and I was all happy with him. He's like, these look really good, but you need to have 34 points and 1 null. And that's what led me to leaving 1 empty, and then that springing effect.
Okay.
So that was, I mean, I've had a few other dreams, but that one was the most game-changing one for me. I gleaned the most information, and I've heard of things through, but I just never paid attention. So like that dream really pulled everything together, and it's like you need to pay attention to this one point.
Yeah.
And I did.
Well, the other thing that I love is you're doing an open, honest inquiry, you know? So many people approach this stuff and they're like, I know this is how it works and this is how it has to be done, and you know, and like with you, it's more of like, okay, here's what I've been able to learn, here's what I'm testing, right? But it's open to change as you learn.
Yeah, completely. And that's why I kind of went back, like this one's so much different than this, but just because of curiosity, and it's simple, you know, it's easy to buy. And once I get the fields down, I can make a system to magnetize that and just see what happens.
Yeah, that's awesome. That's awesome, right? Because I mean, we're human and we're fallible. And again, back in the day when I was doing stories for American Anti-Gravity, I met so many innovators who were like, here's the idea and it has to be followed exactly. And you know, and they weren't open to suggestion. They weren't open to refinement. And that's just a challenge.
Yeah, that is, you get so focused and narrow that it can't be done any other way. Surl said that you can't do it any other way, but yet I look at Floyd's work and he had a solid state, no moving parts. The only thing moving was the magnetic field, and the magnet would move. And that's one of the things we've been discovering. We haven't proved it out, but with that barium has a unique feature about that element is it causes the magnetic field, almost like a time crystal, that it will flip in time. Not mechanically move, but the field will change.
When you talked about the magnetic bubble, that's what I thought. That reminds me of a magnetic circuit, and Tom Bearden was playing with those, right? The MEG.
The MAG, yeah.
Yeah, so it's an actual magnetic circuit in the material that can switch.
Yeah, it's weird. Like how does that change? I don't know, but it apparently it does.
Yeah, so there's, again, it's deceptively simple, right? And you know, I would say that I've looked at the SEG and said to myself, you know, how could this possibly do anything that complex? But then when you get into the magnetization and the fields and putting the AC on it and all that, it's like, oh, this is not simple. It just looks simple.
Yeah, it's just a few layers. Oh yeah. Well, computers in a box look simple relatively, but now they're not.
Yeah.
Very, very complicated. Or quantum chips. Oh, it's just this little chip. Yeah.
Well, and so now that we've stopped it, one thing I do want to zoom in on is these underneath, these are the drivers for it. These are not a part of the official Searl playbook.
No.
They spin, and then the rollers follow them up on top.
Yep. So the big magnets down here, they repel, but yet these smaller ones attract. So it creates like an equilibrium of it pushes the roller away, but yet pulls it to it. And so it creates a magnetic lock.
Okay.
And since the stator holds to it tight, the rollers create this nice balancing point to where it magnetically locks them together. And
so for critics who are like, hey, there's nothing under the table, no, there is a big thing of magnets rotating under the table.
And the motor, if you can, I don't know if it shows it much, but right in the center through the clear, the motor is actually in the center. Directly here and through in the center, it's this tiny little scooter motor, 3-phase brushless scooter motor.
Oh, that's awesome.
It's only a 4-inch, it's made for a kid's scooter, but it takes a max of 36 watts, and I'm not even drawing that much, and it never ever warms up.
And so then with these coils, in past models, these have been what drove the...
Correct.
Okay, so these used to do the work. Now these can be used as pickups for electricity.
Exactly.
Okay.
And they're separated electrically from underneath here. Everything under here is isolated electrically. So that way, when the goal eventually with this is to apply high voltage, which actually I could do that tonight. I did a little bit, and these rollers carry the electrical output, and there's a shower of sparks. It looks beautiful. So maybe we can do that tonight with some video, and I can illuminate this. It'll look pretty crazy.
Yeah, so that would explain. So for anybody, including myself, who was wondering, okay, why is this down below, and why does it rotate? It rotates, it helps keep the rollers level and stable. It moves them around in a circle. And then these are basically pickups for electricity.
Exactly. The other thing me and Jared have talked about this a lot is, before I came up with this formula, is we didn't want a system like Roshan and Godin's that it was all mechanically locked. Like these could not do this springing effect. And so I had to create a thing that the rollers could do all this bouncing, because then you get this nice rippling effect. Like it all had to be independent, but yet connected. So
yeah. Surl, I remember you telling me that Surl had said that these, they will position themselves if you let them, right?
Exactly. All like these. I mean, these are. There's some things I like about the ceramic model. It's so limp and so easy to rotate around. I mean, they're just free to move, but because the magnets are pushing each other away, they equalize pretty much, especially when you get 12 of them, they perfectly center themselves out. And this system does this too, but it's more in relation to the driver underneath. My first model that was like this had a carousel where the driver magnets were here, and it was all encased around. I think that was on the other video you showed, but it was an okay system, but I didn't like it. It was so fully enclosed. I wanted something I could have a nice clean top. I could have inductor coils. Eventually led to that model over there, which, let me pull the cover off real fast. And this one I took to the event last year. This was the first prototype, so it kind of works. So this is where I learned to kind of work the bugs out with the traction system underneath, and that one was a really good working prototype. This Stator unit was the same one you saw last time you came and filmed that I used with the pulses around it. So the magnets here are considerably weaker than that other model.
Yeah, and this is just a very basic demo with one roller, one ring.
Yep. One roller, one ring. It just runs, originally the model I had ran off a much smaller battery, but I had it running off this I could do a 2 amp, there's a 3 amp, 18 volt. And it'll run for probably a couple days on this. And then if you speed up too fast, it loses its grip. But that's because this is the first gen model. And then it lost its traction. First gen, what can I say? Yeah, but that model is far more improved, so it does not lose traction. The other thing I noticed, even on that model, when I would put 12 rollers, it would work better with 12 rollers compared to 6 or 4 or 3 or 2 or 1. It just, 12, it liked 12. Something to do with the magnetic coupling worked fantastically.
Amazing, amazing. Do you want to turn this one on again one more time?
Yeah, let's do it. There's like no wind or anything. That would be great to drop a ball in there and see. I'm definitely going to do that. So later today, I'll put the high voltage right here. I put the negative here and the positive here. When I tried with a Tesla coil, the rollers were picking all the sparks and just showering them all over. It was beautiful. And that was in the daytime I tried that. This is where I get static electricity. Interesting. That's AC. I'm getting a little bit out of it. I believe that's also because of the magnets underneath rotating against them.
So about 8 volts? About 8 volts.
Yeah, it's not a lot. Yeah, it would need a bridge rectifier if I'm going to do DC. A bridge rectifier, and then you can convert it down.
Yeah, and again, this model is driven from underneath.
Still the same voltage, hasn't dropped at all this
So
time.
the magnet carrier driving it is down below, driving the coils up on top, producing 8 volts on the pickups. Yeah, this is truly remarkable, Isaiah.
The next one after this, I'm going to do version 7. Because these magnets are fully glued in. They are set. They're not coming out. But version 7 will be the ones with patterns and everything.
Ah, okay.
Yeah.
Man, you were making the dream come true.
There is
After decades. Decades. I mean, Surl is like this legendary myth, right? Like,
so much urban legend behind him.
yeah.
There is a trick. I have yet to prove it, but I believe it will work. That if you cut these stator magnets right, and put them together. Typically when you do north and put them together, they repel. There's a trick. I have to try it yet, but I believe creating these the right way, when you put them together, they come together and stay.
Okay.
And it's the way that you shape them. So I have, it'd be a very, well, it won't be too expensive. I'll have to try it and then I can confirm it's true, but it is a conceptual idea I have of shaping these to form the stator, the one that come together. Like if you were to do, north and south, they will of course want to go together. But I want everything also, all the magnetic directions all the same. There is a way I'm formulating that basically you could put them together and they stay without falling apart, flipping apart, magnetically pushed away. So we'll see if that works or not.
Interesting, interesting. And then with this one, like, are you now? So now I've got the bug planted. Are you thinking about doing like laser deflection or anything like that? Yeah.
Oh yeah, I'm gonna have to try that. I've heard of that 2 decades ago, right? Laser deflection and use the electromagnets to deflect the laser beam. I just never thought of it with this, but that would be. I mean, I could put the thing over there and the target over there, and just watch it.
Yeah.
That's brilliant. I will do that.
I'm wondering if you could use a laser level for that. I mean, if you wanted it super precise, you could do interferometry, but who knows? Maybe even just a laser level would be enough to see if you get deflection.
Yeah. You have a target quite a distance away, turn it on and see what happens.
Yeah. And again, I wouldn't expect anything, but who knows? Stranger things have happened.
And that's the thing, is you got to try.